Here's another problem from section 3.3. We're given a curve and we're asked to find the line perpendicular to the tangent to the curve. Now, a line that is perpendicular to the tangent is just another way of saying find the normal. So the first thing we need to do is find the slope at this particular point to 3. So I'll take the derivative. I get y prime on one side. I get 3x squared minus 3 on the other side. Now, remember, that is the slope function. It's not the slope. It's the slope function. So what I want is, what is the value of y prime when x is equal to 2? And that's equal to 3 times 2 squared minus 3, which is equal to 3 times 4 minus 3, which is 12 minus 3, which is 9. So that's the tangent line slope. At x equals 3. So the slope perpendicular to the tangent is going to be negative 1/9. So we have a slope of negative 1/9. We have a point 2,3. My equation is going to be y times negative 1/9 times the quantity x minus 2 plus 3. Expanding this out, this is negative 1/9 x plus 2/9 plus 3, or negative 1/9 x plus 2/9 plus 27/9, which is equal to negative 1/9 x plus 29/9. In problem 39, we have a curve. Y is equal to 2x cubed minus 3x squared minus 12x plus 20, and we're asked to find where the tangent is parallel, to the x-axis. Well, all the lines that are parallel to the x-axis have a slope of 0. So another way of saying this question is, where are the horizontal tangents? So let's start by finding the derivative of 6x squared minus 6x minus 12. Let's set that derivative equal to 0. Now let's factor out a 6 to make our lives easier. Let's see, is there a factorization for that? How about 6 or x minus 2 and x plus 1? That seems to work. So when x equals 2 or x is equal to negative 1, the tangent of y equals x cubed minus 3x squared minus 12x plus 20 is parallel to the x-axis. In problem number 41, we need to find the tangents to Newton's serpentine. Newton's serpentine is given as 4x over x squared plus 1. We want to find the tangents at the origin, and at 1, 2. So let's start by finding the derivative function y prime. This is a quotient, so we'll use the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Let's clean this up a little bit. 4x squared plus 4 minus 8x squared, and that's all over x squared plus 1 quantity squared. So we end up with, let's call it negative 4x squared plus 4 all over x squared plus 1 quantity squared. So what is y prime when x is equal to 0? Well, it's going to equal to negative 4 times 0 squared plus 4 over 0 squared plus 1 squared. That's going to be 4 over 1, or 4. What is y prime when x is equal to 1? That's going to be negative 4 times 1 squared plus 4 over quantity 1 squared plus 1 squared. So this is going to be negative 4 plus 4 over 2 squared, which is going to end up equaling 0. And we have a problem here. That's not what they say the answer is in the book. Oh, I'm sorry. They asked for what the tangent lines are, not just what the tangent slopes are. So we want the tangent lines. Alright, so coming back to the origin, we have a slope of 4, so the equation is going to be 4 times x, quantity x minus 0 plus 0, or y is equal to 4x, and that checks with the answer in the book. Over here, we're going to get y is equal to 0 times x minus 1 plus 2, and that's equal to y equals 2. And that checks. And that's number 41.